So the next component is the throttle cable. The first type is the pull-only cable. It is lightweight, more flexible, and therefore requires a smaller bend radius. The disadvantage is that it's not designed for compressive forces. The push-pull cable, on the other hand, can handle compressive forces, and drivers report better throttle feel. However, it is bulkier, stiffer, and requires larger bend radius. Now, the last component of the system is the throttle body, and we'll be using the same design as the team has always used in previous years, which is the butterfly valve. It is simple design, easy to manufacture, and it's again tested design for previous years. So right now, I just want to talk about a particular issue of adjustable pedals that deals specifically with the throttle system. Later on in the presentation, I will go back to adjustable pedals and talk about the whole adjustable pedal box as a whole. Adjustable pedals has been a challenge for the team, and one of the reasons is because of the throttle cable. Whereas the pedal required movement to be able to be adjusted, the throttle cable needs to be in constant tension. So there's a conflict there, and there's two ways to approach this problem. The first way is the dependent cable type, and essentially the cable moves along with the pedal. After the pedal is adjusted, the cable would then have to be retensioned. Now, the advantage of this design is it's simpler and requires lesser parts to manufacture, if any. The disadvantage, however, is increased internal friction and inconsistent throttle response, which is not a good thing for a throttle system. The other design is what I call the independent cable type, and essentially the cable is able to remain stationary when the pedal is moving. And just to help you understand, visualize this concept, here's just a SolidWorks model of a concept design that I made. And basically, it's 4-bar linkage with a coupler link that varies in its effective length. So you can see that the pedal on the right there is able to move and click into place, and you'll see that on the left, that link that's connected to the throttle cable does not move at all. So the advantage of this system is it provides uniform cable response and consistent driver feedback. However, it inherently requires more parts to manufacture. So this is the proposed design for this year. Independent cable type adjustable pedals, 4-bar linkage to accommodate the adjustable pedal design, a pull-only throttle cable, and a butterfly valve for throttle body. Now, I mentioned earlier that I wanted to talk about the pedal box. This year, the advantages, of adjustable pedal box is that it would accommodate different size drivers and provide a better driving environment. However, it requires more parts to manufacture, it's heavier, and there's that conflict that needs to be dealt with brake lines and throttle cable. Now, Robert and I wanted to implement a cockpit adjustable pedal box because we saw that it was impractical to require other team members to help the driver readjust the pedals. So we designed this, basically it's a spring-loaded design, one-way default movement, which means that the pedal box by default moves forward and the driver push it forward and it will lock in place. And at that note, I would like to give the floor back to Robert Olson. Thank you.
Alright, I will finish off the presentation with the shifter clutch and the electronics of the vehicle. So what's the point of the shifter and the clutch? It's to change the gears up and down and to disengage and engage the clutch. The goals for this year, we would like to keep the designs the same as much as possible. We would like to tune the clutch engagement. It's a little bit better than it was last year, it's a little lumpy. And we'll optimize the paddle shifting flaps from the previous 2 years' designs. So what options do we have for shifting? We have mechanical, electrical solenoid shifting, hydraulic, and pneumatic. And the types of actuation we considered are foot, hand, button, and flap operated. So for mechanical shifting and clutch engagement, the advantages are it can be lightweight, relatively low cost, can be easily manufactured in-house, and since it is a mechanical linkage, it will be very reliable and durable. However, this can cause slower response times in the shifting. It can include complex pneumatics, and it can be bulky within the cockpit. The electrical solenoid shifting can utilize a button or paddle shifting. It will provide faster response as compared to mechanical shifting. It is relatively simple and easy to shift and use. However, it will require more electrical load. It will be slightly heavy and it will be quite expensive. And much like the solenoid shifting, the hydraulic shifting, we can implement paddle or buttons to use to shift. However, it will be slower response and will be quite expensive and will include complicated electronics. The system used last year was a pneumatic shifting and clutch engagement, and these can either be powered by high pressure air, CO2 or nitrous gas. The CO2 cylinder holds many shifts within a bottle, and it maintains its pressure throughout the life of the bottle. This can be simple and easy to use. It will give us very fast response and shifting times. It'll only require a small electrical load. However, devalving the tank can be very heavy. It can be rather expensive. And the tank will eventually need to be refilled once obviously the gas leaves. We need to keep on top of that. So for this year, the proposed shifting and clutch design is a CO2 power shifting clutch actuation. We're going to reuse the paddle shifting. Again, reuse the button actuated clutch, and we're looking into possibly using a Kevlar wrapped pressure vessel to lighten the weight of the CO2 system. And finish, I'll talk about the electronics for the car. And the purpose of the electronics for the car to operate the engine, to monitor its vital systems, and to execute user inputs. So, components we were talking about there, the ECU, the ignition, the driver interface, and the shifting electronics. And the goals for this year for the electronics, we would like to implement data acquisition. We would like to use traction control. And again, clean up the wiring in the car and maintain the previous components that are in this year's car for next year. So the two ECUs I looked at are the Megasquirt ECU and the Motec ECU. The Megasquirt ECU is a do-it-yourself kit that you purchase. So therefore it has an open source code to it. You build it yourself and you tune it and you design it yourself. However, this time to fabricate and set up is also a disadvantage for our car for this year. And so the other ECU we're looking at is the Motec. And some of the features that are built into the Motec ECU that we can utilize this year are data acquisition. It has software that we can download for free, and it also has traction control that we can use through the use of sensors. However, it is quite expensive and it needs an external ignition source. The two ignitions we looked at are an inductive discharge system and a capacitive discharge system. Some of the characteristics of an inductive discharge system include it has a relatively long duration spark. However, the time it takes to charge up between sparks is relatively long compared to a capacitive discharge system, but it is a relatively simple design. And the capacitive discharge system that we used last year on the car does produce a stronger spark all the way up to a high RPM for the engine. It allows for greater timing flexibility and thus allowing us to increase the performance of the car. And again, the driver interface we're considering this year is the display. It's a simplified display. It will give us a less complicated and cleaner dash, but it will require the drivers who are driving the car to gain some experience with it in order to gain information from that display. And again, for the shifting electronics, we utilize this. It will allow us to shift without lifting the throttle cable, allow for faster shifting times, help in preventing the driver from destroying the car. And however, this does cost money and it does add weight to the vehicle. So, to overview the controls department, we would like to implement an adjustable pedal system, maintain the current brake setup on the car, again utilize the CO2 powered shifting and clutch engagement, and finally to utilize the full suite of features on the Motec ECU. And I'd like to turn the floor back over to Todd.